Welcome student, this is my fourth video of this chapter, pressure, force and pressure. So last video I already explained about the pressures and the relations between pressure and force and area. So and the unit of pressure in SI system. So now today I have more and that day I already explained some of the daily examples how to use the pressures. So now our next example is that your school bag, laptop bag. Perhaps you have seen that when you are carrying your school bag, the strap which you have, this is a broad strap. What is the use to give the broad strap? It may be small. If it, what will be the problem if the straps are thin? So the problem will create. That means your broad strap of the school bag. What this is broad strap means. This is the load of the bag is same. That means force, weight. Weight means force. The weight of the bag is constant. Means you have to take the 8th period timetables, books and stuff. So weight is fixed. That means force is fixed. Okay. So now this is fixed. So how we can less the pressure? That is so that our shoulders get less pressure. So we will increase, our only system is to increase the area of the strap which will just hang on our shoulders. So if I increase A, means if I increase this one area, then what will happen? The pressure will decrease. Okay, since the F is constant, F is not changing because your weight of the bag is fixed. Okay, so if I increase this area by increasing the belt broad, then what pressure will increase and we will get the less pressure on the shoulders and we will become comfortable. This is the reason. Another one, syringe. Perhaps you have seen the syringe. When for blood test, many of you have seen that the pathologist comes and to take the blood from our body parts or hand. So how they just make it vacuum. The syringe they make vacuum. Vacuum means inside the syringe. Inside the syringe they inside, this is the inside the syringe. So this is a needle and one crystal is there. So by this one, first of all, they just push it here and they remove all the air inside the syringe. So what will happen? Then after that, when they pull this one, the crystal one, when they pull it towards this side, so what will happen? That and the blood of the hands. So due to the pressure, we have the blood pressures in our body. So due to the pressure of the blood pressures, the blood will get inside through this syringe and you will see the blood will, as it will move this directions, the blood will get inside through from our body. Okay, so this is nothing but the example of the pressure by which we can take the blood from the human body or any others. Now, a camel has a large padded feet which increase. Perhaps you will see that why the camel, the camels with the so heavy weight and camel easily can run on the sand, but with a human being cannot run on the sand. The reason is same, because the camel has a large padded feet. The camel has a large padded feet. This large padded feet means A is more. Since the area of the large padded feet of the camel, so that's why what happened, whereas the human being's feet is not that much, area is less and the camel's feet are large. So area more, since area more, the pressure will decrease. So that's why the camel while walking on the or running on the sand, they get very less pressure so that their legs are not yielding, not getting inside the sand. Whereas the human feet, the area is very less and as the area less, so pressure increase. And that's why the pressure increase and their feet just get inside or yield inside the sand, and that's why they are facing problem to walk or run on the sand. This is also the example of the pressure. Now, water, now the dam. Now, like, now have you seen the many dam? Now near your school having the punctured dam. But if you observe the dam wall, the hull, the upper portion is thin, but down portion is just broad. That means this much broad. So why the down portions is broader too much? The dam wall, upper portion thin and down one broad. Why? Because we know the dam wall, the water is too much. So due to the water, the liquid, the water exerts too much pressure to the wall. So as the depth increase, as the water level increase, the pressure also increase. So this one, to decrease the pressure on the wall, we just make the bottom of the wall wider. Bottom of the wall wider. That means we are increasing area. If we make the walls wider, the wall down portions wider, so we increase the area A, and if we increase area means we decrease the pressure. In this way, we can less the huge water pressure on the wall very less and make our wall strong. Now, as porters place a piece of cloth on the. Perhaps in the stations you will see the porters put a piece of cloth on their head and to keep the load. Okay, why they put the piece of cloth on their head before taking the luggage on their head? Because that is also same thing. If they directly put the luggage on their head, then what will happen? The area in between, the touching area in between the luggage and the head will be very less. That means A will be less. If A will be less, then P will increase. So the porter will get more trouble or more pressure to carry the load, and he will become tired, and also he may be uncomfortable. So that's why he put a piece of cloth here to increase the area or touching area of the object and the head. So since touching area they are increasing by including a cloth here, cloth, so means they are increasing the area. Since they are increasing the area, so they are decreasing the pressure, and that's why the porter can easily carry the huge luggage. There is no without any problem. Okay, this is now pressure exerted by fluids. Which one we call fluids? Fluids, that means gas and which can flow. This material is called fluid. So which can flow? Fluids. Fluids is liquid and gas. These two called the fluids. So fluids, liquids and gas. These both can exert pressures. Now I am coming the pressure exerts by a fluids. Suppose if I take a balloon, you easily blow the balloon. So why we pour in a balloon, we just pour air inside. So as we blow the balloons, the air get inside the balloons and the air giving pressure to the balloons, and the balloons plunge, and so the air giving pressure to all directions, so the balloons bulge. So that means fluid can exert pressure to the wall of the balloons. That's why the balloons can blow. Similarly, and the liquids, if you blow more, if you pour more air, then what will happen? The balloons will burst. Why it will burst? Because beyond its capacity, the balloons cannot tolerate this much pressure of the air or gas. That's why it will burst. So it will a very common example that gas can or air can apply exact pressure on the wall of the balloons. Now next I am coming to the pressure exerted by a fluid. So what pressure exerted by a liquid? So pressure exerted like the bottom of the container. If you take the water, now what experiment you can do, that what if you take a bottle, the Bisleri bottle, any bottle, and you make 3 holes here, 3 holes, and if you pour water up to here, then you see that what the water is flowing like that, and the last one like that. So as why in 3 directions, 3 distance, the distance from the bottle, the 3 flow will come like that. This is due to the pressure of the liquid. Since it is as though liquid, how the liquid pressure will increase as the depth will increase from here. Depth means from up to down we have to go, then we can measure the depth, not down to up. We have to make the depth from upper side to lower side. So as we go downwards, to see the depth of this point A, B, C. The depth of the A point is much lesser than the depth of C, and B is more than A but less than C, but C is more than B and A. That's why since the depth is maximum here, the pressure of the water will flow like that. And it is less than C, then it will come just after the AC, and after that A also come, then it is the less pressure, water pressure. So from this experiment, if you can do at home also by taking a Bisleri bottle and making 3 holes and pour water, after closing the holes, if you pour water and if you open this water at a time, you can see these types of observations. So that proves that the liquid or water, whatever else, the liquid exerts pressures as the depth of the liquid increase. Okay, so now another experiment also you can do, that is, and one more, and at the same height, if you make a 3 holes, then you see the water is falling from the, if you take it at the same level, if you make 3 holes and pour water, then you will find that all the water spring is also same in equal distance. Why? Because the water level at the fixed depth is equal to all directions. That means on the fixed level depth, the pressure is same in all directions. But if I increase or decrease the depth, then the pressure will increase or decrease as per the level of the water. Now another experiment you can do, that is at home. If you take a small bottle and at the end, if you put or tube, if you take tube and put a balloon here and tie it nicely, and so if you pour little bit water, you will see the balloons will bulge little bit. But if you pour more water, you will see the balloons will bulge more, bigger than previous. So what does it mean? That means as the water level increasing, the water is pouring more pressure. That's why the balloon is bulging. Okay, so this experiment also you can do at home. So in this way, we can observe that the liquid exert pressures as the depth will increase. That's why the bigger dam, we make the broader wall, the bottom of the dam wall to decrease the pressure of the liquid. Okay, now my next video I will explain you about the pressure exerted by gas, and I will discuss some questions in the last video. Okay, in this way I will finish this chapter. Thank you.